Okay. So, yesterday you learned or reviewed the subatomic particles, correct? I need you to calm down. I understand that, but there's no need to act foolish. Alright, so you reviewed the subatomic particles, correct? You have to know those. Okay? Ricky, give me the 3 subatomic particles.
Electron, proton, neutron.
Okay, very good. You have to know those 3. You have to know the charge. So as you're walking in, I was asking you, correct?
Yes.
So, Princesa, what's the charge of a proton? Positive. And Mariana, what's the charge of a neutron? Charge of a neutron. I said Mariana. Oh, sorry. Marissa. Mariana sits right there. Okay. Charge of a neutron. No charge or neutral. That's the word we need to remember, right? And Abby, what is the charge of an electron? Negative. Very good. So you just have to know those. Then you have to know the location. So, Brian, what is the location of the protons? In the nucleus. Very good. Jared, what is the location of the neutrons? In the nucleus. And then Antonio, what is the location of the electrons? Outside the nucleus, and we call that what? The electron cloud. Okay? So you just have to know that. Then you also have to know masses. Ethan, what is the mass of a proton? Okay? Levi, what's the mass of a neutron? 1. So remember, both proton and neutron, 1 AMU, right? And Zachary, what do we need to know about the mass of the electron? Because we don't know the number, but what do we need to know about the electron compared to the other 2? Think of a penny. So how much more? A lot smaller. So remember with the electron, you don't need to know the number because it's 1 over 1834, something like that. I don't even know the number. It's really, really small, right? You just have to know that. So don't come to me and say, Miss, I don't understand the subatomic particles. I'm going to say, what don't you understand? I don't understand protons positive. You don't need to understand that. It is what it is. Think back to kindergarten. They said to you, what color is this?
Yellow.
And kindergarten said it's yellow. Did you sit there and say, why is it yellow? I don't understand that it's yellow.
Why?
No. You just have to remember that this is yellow, correct? Now, there is a reason, and we'll talk about it when we get to light and optics, but this is yellow. You learned it was yellow, and that's all you have to know, right? With a lot of this science stuff, this terminology, you just have to know that protons are positive, that they're inside the nucleus, and their mass is 1 AMU. There's no understanding. It is what it is. Yellow's yellow because it's yellow. Okay? Proton's positive because it's positive. Now, there's a reason, but you don't need to know. Okay? All right. So, we're going to move on. And now that we know about these subatomic particles, we're going to learn how to draw the atoms. So how to draw these subatomic particles and how many you need for each atom. Alright? So before we go into drawing, we need to think about when we draw them, we will be drawing them in something called the neutral state. All atoms really want to be neutral. When we look at the periodic table, we're going to assume that all those atoms are neutral. So when we draw them in the neutral state. So let's talk about this word neutral. What does neutral mean? What does that mean? No charge. Remember, neutrons are neutral, so it means that they don't have a charge, right? So atoms don't want to have a charge. They want to be neutral. Well, there's 3 subatomic particles, correct? Protons, neutrons, electrons. Okay? So Ethan, can you tell us once again what the charge of the protons are? Positive. Leslie, can you tell me the charge of the electrons? Negative. So inside the atom, I have charged particles. I have positives and I have negatives. But somehow, my atoms are neutral. So how can this be if I have charged particles inside the atom, but the total charge of my atom is neutral, meaning it doesn't have a charge, it's 0. How can I get a neutral atom? Yes?
Does the positive charge and the negative charge cancel out?
Very good. The positive charge and the negative charge cancel out. That means that what 2 particles have to be the same? Protons and protons are positive and electrons are negative, correct? And that's true. That is completely true. Protons must equal the electrons so they can cancel the charges out, so the atom ends up with a charge of 0. That way, bless you, the atom is neutral. Okay? So, Andrew, there you go. Can you explain to me once again why the atom is neutral? Because the positive charge cancels out the negative charge, and how can that be? Why does the positive cancel the negative? Because they're equal? Okay, very good. Because my protons and electrons are equal. Alright? Princesa, can you repeat for us again what, or why atoms are neutral? Okay, very good. Alright, Leslie, can you explain to us once again why atoms are neutral? I'm sorry? Okay, Jared, can you explain to us why atoms are neutral?
Because the protons and electrons cancel each other.
Okay, very good. So, Leslie, can you tell us again? Very good. So, if I have protons and electrons the same, they're going to cancel each other out. We just said that 5 or 6 times. Do you think that's important?
Yeah.
Yes, you make sure it's in your notes. It's important. Alright? That's what our protons and electrons, when we draw them, we're going to draw them equally because the atoms are neutral. Now, in about 2 weeks, you're going to see that that's not the case all the time. Because sometimes you're going to have an atom that has, let's say, 8 protons. And what is the charge of protons again? Positive. So 8 protons would be a charge of a plus 8, correct? Can we all agree with that? Alright. So, and they have 6 electrons. And Abby, can you tell us the charge of electrons again? Negative. So that would be a charge of negative 6, correct? So, if I have a positive 8 protons, and a negative 6 electrons, what would be the total charge of that atom? 2 what? Positive or negative? Positive. Positive 2. That would be an atom that is not neutral. Later on we're going to see that we do get those. But for our purposes of drawing, we will always draw neutral. Okay? And we're going to see why we have to have positives and negatives. So, let's move on to the actual drawing. So before we actually start drawing, I'm going to go through the steps of what you need to do in order to get to your drawing. Okay? So the first thing you need to do is you need a periodic table. Okay, so anytime you're about to draw an atom, you're going to need a periodic table because you need to look at that. You need to look at the element key for that element that you want to draw. So let's say we were going to draw oxygen. We would look at the element key. Now, we would look at 2 things on that element key. We would look at the atomic number and the atomic mass. Now, do you think that every single periodic table in the whole wild world has the atomic number at the top and the atomic mass at the bottom?
No.
No. Because scientists like to change different things, and some periodic tables have a lot more information than others. Okay? So, what could you tell me is the difference between the atomic number and the atomic mass, Alexis? So what could you tell me that the difference is between the atomic number and the atomic mass?
The atomic number is like how many protons?
Yeah, but just looking at those 2 numbers, how could you distinguish between the 2?
Oh, the atomic number is less than the
Okay. And what else? What other things that we see different, Brian?
The atomic number is half of the atomic mass.
Okay, sometimes it will be, but not always. Okay, what else? Andrew, yes?
The atomic mass has a whole lot of decimals.
Say again?
Has decimals.
Okay, very good. The atomic mass is always going to have decimals. even if this was 15.000, they would still write 0.000. Okay? So your atomic number is always going to be a whole number with no decimals. Your atomic mass will always have decimals. And Alexis is correct. The atomic mass will always be more than the atomic number. Now, sometimes it will be double, but sometimes not. So don't go with that. Alright? Now, once you are able to find the element that you want to draw, you're going to want to find its protons. The way you find the protons is by looking at the atomic number. And the reason for it is because you're going to think of the word 8. 8 stands for atomic number is equal to the protons is equal to the electrons. Okay? It's my hope that you've already talked about that in previous years. Okay? So I'm hoping that you've seen this before. Okay? 8 stands for atomic number equals protons equals electrons. So, Zachary, if I say that the atomic number of carbon is 6, how many protons does it have? 6. Very good. Easy, right? Abby, if I say that the atomic number of zinc is 30, how many protons does it have? 30. Okay? Leslie, if I say that the atomic number of osmium is 76, how many protons does it have? 76. Is that hard? No. Protons are very simple. All you have to do is look at the atomic number. So, everyone, if I say that phosphorus atomic number is 15, how many protons does it have?
15.
Okay. If I say that krypton's atomic number is 36, how many protons does it have?
36.
Now, I can go backwards. If I say that calcium has 20 protons, what's the atomic number?
26.
If I say that cesium has 55 protons, what's the atomic number?
55.
So, right now, I could give you any number of protons, and you should be able to tell me the element, right? Okay? That's why I don't make you memorize periodic table, because as soon as you know all these little tricks, you don't need to memorize that. You can find that out. I don't need you to memorize the entire thing, but you're going to have to be able to read it. So right now, if I asked you for the number of protons of every single element on that periodic table, could you give it to me?
Yep.
Yes. Because it's equal to what, Brianna? Whatever the proton's equal to. So could you look up there and see any of those atomic numbers and give me the number of protons? Yes. So if I ask you for any of those elements, could you give me the protons? Yes. Because it's just the atomic number, right? Easy. Second one is very easy too, which is finding the electrons. Well, what did we say the electrons have to equal to in order to have a neutral atom? Protons. So for the electrons, we use 8 again. Atomic number is equal to protons is equal to electrons. So here we go again. Cobalt has atomic number 27. Ethan, how many electrons does it have? 27. Brian, zirconium has atomic number 40. How many electrons does it have? 40. Alright. Janae, bromine has atomic number 35. How many protons does it have? 35. Isn't that one easy too? Okay. Now, Edgar, krypton has 36 protons. How many electrons does it have? I'm sorry?
36.
36. Because what do we know about all three numbers? Atomic number of protons and electrons?
All equal.
They're all equal, they're all the same. Okay? So, protons, electrons, very easy. The next one, a little more complicated, but everybody in here is in algebra, so everybody can do it. Which is finding your neutrons. Now, finding the neutrons takes 2 steps. The first one is to look at the atomic mass and calculate what we call mass number. The mass number is the rounded atomic mass. So the first thing you're going to do before you find neutrons is you're going to find the atomic mass, which remember is the number with decimals, and you're going to round it to its nearest whole number. So, oxygen's atomic mass is 15.999, or 94. So if you round it, Zachary, it would be 16. So the mass number would be 16. Okay? Diego, The atomic mass of aluminum is 26.98. What would be the mass number? 27. Very good. Gabriel, the atomic mass of nitrogen is 14.0067. So what would be the mass number? 14. Very good. And make sure that you use correct rounding rules. So if it's 0.5 or above, you go up. If it's 0.4 below, you just drop the decimal. Okay? So make sure you do rounding rules correctly. Once you find the mass number, then you can use man to find the neutrons. Man stands for mass number minus atomic number equals the neutron. Now, do you see how I put mass number here? You need the rounded number, because if you put atomic mass, aren't you going to end up with decimals? You can't have part of a neutron. That doesn't make any sense. Okay, so make sure it's mass number minus atomic number equals neutron. So I already heard it. That's what you need to remember. 8 man. I'm trying to find protons, neutrons, electrons. I'm going to use 8 man. 8 for protons and electrons, man for neutrons. Okay? So everybody in here can remember 8 man. I'm sure. Okay? So once you find protons, neutrons, and electrons, then you're ready to draw. Okay? Now, when we draw, we're going to draw the subatomic particles where they belong. Correct? So, Abby, can you tell me where protons are located? In the nucleus. Very good. Okay? Edgar, can you tell me where neutrons are located? Nucleus. So, the first thing you're going to draw are protons and neutrons because they're found in the nucleus. Okay? So in this case, how many protons do I have, does oxygen have?
8.
Okay? And for neutrons, I would have to do 16 minus 8, which gives me 8. So I would put those in the middle. So my next step after finding those is actually drawing my protons and neutrons inside the nucleus. Basically in the center, because you're not going to draw a circle for the nucleus. You're just going to put them in the center. Then after I find the protons and neutrons, I'm going to find the electrons. So, Andrew, where are electrons found? What side of something?
Electrons?
Yes, electrons.
Outside the nucleus.
Outside nucleus. What do we call that area? The electron cloud. Okay. Now, since remember we talked about yesterday, and we looked at 2 models, and I said the Bohr model, and I said the electron cloud model. Okay. And I said, unless you have some fancy gadget that you can draw and the electrons are going to move on its own on your paper, you're going to have to draw them as a Bohr model. Okay? So, Bohr came up with the idea that a certain amount of electrons are found in certain energy levels or orbits. Okay? So, when we're drawing the electrons, we're going to draw the electrons on orbits or energy levels. The first energy level can fit 2 electrons. The second one, 8. The third one, 8. And the fourth one, 18. And as you're writing this, you're thinking, oh man, I'm going to have to memorize those numbers. Well, guess what? You're not, because you're going to be able to find them on the periodic table. And the reason for it is because as we're going to look at the periodic table next week, we're going to see that we have a bunch of patterns. So I'm going to talk about one of the patterns right now. So I want everybody to stop writing what you're doing. And I want everybody to look at that periodic table. So stop writing and look at the periodic table. Alright, periods are rows going across. So period 1, the row going across, how many elements are over there? 2. Hydrogen and helium, right? How many electrons can I put on that first energy level? 2. Period 2, going across, how many elements are in that period?
8.
How many electrons can I put on the second energy level?
8.
Period 3, how many elements are going across?
8.
How many electrons can I put on that energy level?
8.
Period 4, 4 going across, how many elements are on there?
18.
How many electrons can I put on that one?
18.
Do you have to memorize, or do you all you have to do is count?
Count.
It's on the periodic table. You don't have to memorize those numbers. You just have to say, oh, period 1 relates to level 1. Period 2 relates to level 2. Period 3 relates to level 3. Period 4, level 4. So how many do you think you can put on level 5? 18. Now, level 6 and 7 are a little weird because in the periodic table you have these elements down here that actually belong in there. So it's actually 32 and 32. Okay? So, any questions over the different steps that you need to take as you draw? Alright, so now we're going to practice. And yes, it should be included in your notes. So we're going to practice drawing, well, we've been drawing oxygen, but I don't think that's been working very well. So we are going to practice drawing sodium. So we're practicing drawing sodium. Oh, wait a minute. I'm sorry. Let me go back. Last thing you need to do. After you draw the atom, I want you to do one more thing. I want you to tell me the number of valence electrons that are in that atom. All valence electrons are the number of the electrons on the last energy level, on the last circle. So that last circle that you draw, however many electrons you have there, that's the valence electrons. For right now, that's all you need to know. We're actually going to use them a lot in about 2 weeks when we start talking about bonding. So the last step I want you to do when you're drawing these atoms is I want you to tell me the number of valence electrons. All valence electrons are the number of electrons on the last circle. Okay? So this is what I want to see when you are doing one of these problems. So sodium. The first thing you need to find out about sodium is what's the atomic number. So what's the atomic number? It's Na. Yes, it's part of your notes. Alright? And what's the atomic mass? 22 point what? 989? Okay, we'll stop there. Alright. Now, my first step is to find protons, correct? Can I take this out now? So I'm looking for protons. What do I think about when I think about protons? 8. Very good. 8. 8 means that protons are equal to the atomic number. So how many protons does sodium have? 11. Because isn't the atomic number 11? Okay. Then I'm gonna need to find electrons. When I think of electrons, what do I think of? 8 again, which is, you're right, is equal to the atomic number. So how many electrons am I going to have? 11. Oh. Yeah. Correct? Okay. And then neutrons. What do I think about when I think of neutrons? Man. Man stands for mass number minus atomic number, correct? Now, how do we get mass number again? Round what? Round the atomic number. So I have to round this to get the mass number, right? So if I round 22.989, that will give me 23. Very good. Bless you. So 23 minus 11 gives me what? 12. So now do I have protons, neutrons, and electrons?
Yes.
So I'm ready to draw. Okay? And what am I going to draw in the nucleus? Protons and neutrons. Very good. So how many protons do I have? 11. Now, some of you might want to draw a bunch of little circles. I'm lazy and I don't want to do it, so I'm going to write 11. But what can I put beside this 11 to tell me that those are protons?
Positive.
A positive sign. Very good. Or if you want to put P, that's fine. But the thing is that I need you to start relating proton to positive. So it's one way to kind of exercise and do that. Alright, so then what Brianna said that I needed what else in here?
Neutrons.
The neutrons. So how many neutrons do I have? What symbol could I put beside that?
Negative.
No charge.
No charge, which means it is a 0, right? Not a negative and positive, but a 0. Because think of it, +5 and -5 give me 0. So, neutron. Then I draw my electron. So I draw my first energy level. How many electrons can I put on this first energy level? 2. Now, how many do I need to put total of? 11. But I can only put 2 in here. So I usually put circles with little negatives inside because electrons are negative. So if I have 2 and I'm not done yet, I'm going to have to draw another energy level. And how many can I put on that one? Up to how many? Up to 8. Do I need to put all 8 on there?
Yes.
Yeah. Yes, right? Because I
Yes.
need to put 11 and I only have 2. So if I put 8, that gives me a total of what? 10. So since I filled that up, then I need to put another one. And I only need to put 1 there. So I know this is correct because I have 11 protons in the center. 11 protons. 12 neutrons. 12 neutrons in the center because both of these are in the nucleus, right? Then I need 11 electrons, 2 on the first one, plus 8 on the second one gives me 10, plus 1 on the other one gives me 11. Now, the last thing I want you to write is the number of valence electrons. And what did I tell you those were?
The last electron on the
The
last
electrons on the
ring.
last.
So the last ring, and how many would that be?
1.
So when I ask you to draw atoms, that's what I want to see. I want to see how you got protons, neutrons, electrons. So I want to see this top section. I want to see your Bohr model, and then I want to see how many valence electrons you have. Okay? Any questions on how to draw it? Okay, so this is what you're going to do. On the opposite page of your notes, so your notes are on page 45. On page 44, you're going to split that page in half, and you're going to draw me aluminum on the top and calcium at the bottom. So everything we just did on this page, you're doing on here for both of these. As you're working, I'm going to come around and just kind of see how you're doing. I also want you to talk to each other if you have issues, or ask me. In about 10-15 minutes, I'm going to come around and you're going to stamp if you got them correct. But don't worry, because I'm walking around and making sure that you're doing it right. Now, the stamps that I give today and tomorrow, because I'm going to stamp your atom foldable tomorrow, those stamps go on the next 6 weeks, not on the 6 weeks. All right? Now, so this is what you need to do. You need to work on these two. When you're done, leave it open so I can stamp it. And then work on your atom foldable. Because now you're able to do all 5 questions. Yesterday, 1, 2, 3, and 4 were covered. Today, number 5 is covered. This will be stamped tomorrow, so you need to make sure it's done and put into your note. Alright? So any questions before I let you get to work? Okay, then get to work. Yes, all your work should be on. You need a pass?